third day in conference after lunch is not good time to do this kind of technical session. Let's see, but I will try my best to wake you up and keep with me. Okay, so I will start with this slide. So if you are old enough like me, 20 years back, normally we develop applications, we test it on our machine. Then normally we do either SCP or FTP into the remote machine and deploy. There's nothing in between. It's that kind of simple. But if you look at the current cloud native era, so when you write a code and run in production, there are a lot of repetitive tasks in the middle we have to do. So we have to do like a code analysis, then vulnerability scanning, then build the container images, container scanning, and push into the registries, and do integration testing, and then promote different environment. There's no dev to production directly. There's a dev stage and production, and also like then we need to have a lot of observability because it's not a single application now. We have to collect all the logs from everywhere and correlate all these logs and traces everything. So it's not an easy. So to write a code and run in production, there are a lot of repetitive tasks we have to do. Because of this, like in today's world, people, our organization are trying to build a platform to manage all these repetitive tasks. So this is the Gartner hype cycle. In 2024, you can see, you can't see. So basically, believe me, it's in top, it's an internal developer platform. And then next to this, internal developer portal. So this is, everyone try to build platform, everyone try to build internal developer platform. So I think Nuwan did like a very good session. So what are the principles we need to think of developing internal platform? So this was very trending in 2024. Now if you come to 2025, that trend's gone down, but now it's getting to the productivity plateau. So basically now people realize, okay, how we can increase the productivity by using internal developer platform. So it is into the mainstream now. So let's look at what is this internal developer platform. So like I said, Nuwan did, okay, categorize the 10 key principles to have in internal developer platform. Let me try to make it more like the feature level. So these are the things when you are analyzing the internal developer platform should have. When you are aligned with the 10 principles, what Nuwan has talked about. So one of the main things in here, many of the other internal developer platform only focus on your right-hand side. So people think of internal developer platform are only that manage the software delivery and the operation. So that's one of the mistakes we have seen. We talked about a lot of customers. We engage with a lot of customers. So that's the industry looking at in only that angle. But if you think of that aspect, if you neglect the software engineering aspect, then when you try to, after you building something, when you try to push in production, there's a friction in between. So our definition is when the internal developer platform should be thought from the software engineering perspective as well as the software delivery and operational perspective. So this is where even end of the Nuwan session, there are a lot of questions. So one question was okay, so how I am familiar with the CI circle CI/CD, and then I want to do maybe a GitHub action. So this is where that happened, because the operational things are leaked into the developer. It shouldn't happen. So if you look at the internal developer platform, it should abstract proper way that developer only focus on write a code, test it out, debug it, again write a code, that cycle, right? That's the productive cycle of the developers. So then if you are not think this as in the first class, this operational and this delivery concept are leak into the developer, then all these problems arise. So when you look at the software engineering aspect, like API first design, domain-driven design, everything needs to be think as a first class, and then map into the development or delivery or operation cycle. I will discuss detail. Okay, so this session mainly focus on platform engineers who are trying to build intelligent platform, or at least a platform. So, so here what I'm trying to tell you that what the challenges we face to adhere these 10 principles, and how we overcome, what are the strategies we took to overcome. And then in end of the presentation, I will give more detail. I can talk about hours and hours of technical details, but with these 25 minutes or 30 minutes, I will make it more high level. But if you want more detail, please reach to me. I will let you know more detail. Okay, so this is the ultimate experience that internal platform should have. So first aspect is engineering aspect, where software design start with either domain design, then how the team structure build around that, and then how these different teams discover the services, APIs within the organization. This is one of the other problem we have seen in a lot of organization. When some in the large organization, there are a lot of duplicates happen. Like so, because there's no way to discover the other services that built it by the different team. So all these things need to be consideration as a developer experience or ultimate experience. Then other question is, when you deploy something into the production, then we should have a proper mapping. Okay, this deployment, this runtime is mapped to a domain what we design in the design time. This principle or the deployment should govern or like a monitor. And so if you come to the microservice architecture, so we are advocating that smaller team get autonomy to do whatever, choose the programming language, and there are a lot of autonomy. They can use different technologies. Now, but if you deploy into the production, that autonomy shouldn't be break the other developer teams' work, right? Then how you should be isolated your design principle in runtime as well. So all these things need to be think through and develop your internal developer platform. Okay, so I put some of the challenges. There are more, but like a time constraint. So let's go to a few challenges. So one is the obviously, this is what I discussed, bridging development and the operation. So these are the things we need to think, okay, the different team, now they are doing their own stuff, and when to come deployment, how you can manage. So I will discuss how we overcome that. Then the scalability across dimension. So it's not only the scale based on the traffic. This is scale all the cross sections. It's scaling from the how you can add a new team to your organization and use onboard into the development process. How you can fast deliver your feature delivery into your production system, and how now when you are defining when you are developing into your platform, how fast you can develop the feature. Delivery of your individual features into the production. All these things come under the scalability across the dimension. That's also a challenge one of we face. Then we start our IDP in Microsoft Azure Cloud at the first step. We went with the GA. Then just after we hit the GA, a lot of customers request, okay, I want to run my internal developer platform AWS. I want to run in GCP. Someone want to run in on-prem. So this is where you should have a proper think in the beforehand. Okay, if you want to deploy your internal developer platform across the multi-cloud or multi-region, you should architect at the first place. Run anywhere. Again, so every organization having their own system of records, right? It's either if you are starting a new company, but if you are in the market, sometimes definitely you have some system of records. So it's running somewhere. So then your application, that your developer building application should run near to your system of records, near to your data. So that need to be think upfront designing the internal developer platform. Then accelerated feature delivery. So basically, like I said, in the first step, we start with the Microsoft Azure as our cloud provider. Now we integrate Microsoft cloud provider feature services. Now then we want to deploy into the AWS. With initial thought, okay, why not we can integrate to the AWS services. For example, say we are using Azure log analytics. So why not we are integrated with the CloudWatch? Then the question is, okay, how fast we can deliver that feature? When we introduce a feature to the log visualization, how fast we can put into the AWS? We have to redo the same thing with the APIs in the CloudWatch. So then we realize, okay, you can't do that with this kind of strategy. So that's another challenge we face. Then the compliance adherence. Okay, so now because of now we are using cloud provider. Now then the observability data and all other data need to be in the cloud provider itself, right? Now if you are running on-prem, if you are using a Azure cloud log analytics, we need to publish into the outside of the cluster. So then a lot of compliance issues came into as a challenge to us. So we have to come up with a solution to that. Then the built-in zero trust security. So there's a report saying that the latest organization or the current organizations, because of microservice architecture, deliver averagely 11 new services into the production in a given month. So when you are putting a new services into the production, that means we are broadening up the threat surface because new services need to be protected and secure. So if you are delivering this kind of frequent features, then we can't do feature release by release security enforcement. So we should think through, okay, as a platform, how we can secure, how we can enforce zero trust security inbuilt into the platform. Then it's come with the governance as well. So I think we discussed a lot of previous talk also discussed. Okay, now we are giving autonomy to the developer with the microservice architecture. They can use any tools. Then we have seen end of the day, no one know what technology used in the stack, and what services call, how many microservices running. So these things are then this will be a nightmare for the CIO. So basically, this is for not only the developer, like previously we discussed, this internal developer platform for an entire organization. There are a lot of personas, developer, platform engineers, CXOs, CIOs. So basically, everyone should be part of this platform. Then we need to think what are the capabilities they require to govern their developers' feature delivery. Then observability and monitoring. Obviously, because of, again, microservice architecture, it's not a single application we are running now. So I'm pretty sure you have the engage this. So when you are troubleshooting, there are a lot of moving parts. So observability and all the monitoring should be inbuilt into the platform. Otherwise, you can't troubleshoot this kind of distributed system. Last part is cost optimization. It's cool. We can build a very nice, very elegant platform, but end of the day, we have to pay the bill, right? So if you can use all these cloud services, so we have to. There are huge bills comes into the play. So I can give one example. Even internally, so we have this cloud data plane. We have shared data plane. We were able to reduce $20,000 per month just moving away from the cloud provider log solution to the cloud diagnostic solution. And one of our customers saved $3,000 per day, just moving from the CloudWatch to our observability stack. So this is the saving we are discussing. So it is, we can develop nice platform with all the services, but we need to think of the cost optimization as well. Okay, now these are this is not the only challenges. I just listed a few. Let's look at what are strategies we took to overcome these challenges. I think this is, again, no one discusses one of the principles, so separation of the concern. So basically, one decision we took is, okay, separation of the control plane and the data plane. So because of this, we get a lot of scalability benefits. We can run our data plane in anywhere with larger scale near to the customer data. And also, we were able to separate out the management traffic and the runtime traffic, and we were able to adhere to the compliancy. Then the important thing is adhering to the right architecture. So this is very critical. So I will discuss few architecture patterns we use. So what are challenges we overcome? We were able to map software engineering principle into the software delivery principle by adhering these architecture patterns. Obviously, scalability. Then we were able to adhere to all the compliancy requirement to run this platform. And because of this architecture, we were able to bring built-in zero trust security. Then whoever the developer just deploy a component into the platform, it by default is secure and enforce the zero trust security. And we were able to bring enterprise governance by using this adhering to right architecture. Then I will go detail of adapting the cloud agnostic solution. So basically, one is the cost optimization I discussed earlier. Other one is because of this, we were able to run in multi-cloud, multi-regional. And like I said earlier, we thought of, okay, we can use Azure Log Analytics, and we can use AWS CloudWatch, Google Stack Driver, likewise. But you can't do that. If we are doing that, then it is a lot of overhead to the engineering team. When you are doing a feature release, you have to do multiple coding for the different cloud. But when you adhere into this cloud agnostic solution, we were able to do a feature release. One release, it will work across all the cloud provider or even on-prem. So this is one of the challenge we took, but it gained a lot of benefit out of this implementation. Yeah, let's move on. Okay, let's look at the key architectural pattern we adhere. So again, this control plane and data plane separation. With the control plane, like Nuan said, it's just a matter of controlling signals. So I send a signal to your data plane. Now, your data plane can run on any cloud provider. It's just a matter of required Kubernetes cluster and networking and storage. It's barely using the infrastructure level features. On top of that, we have a lot of other software layer we are installing. And because of that, we were able to run the same architecture, same software stack across all the cloud providers. Then the right level of abstraction. So Kanchan also talk about this. So this is very key thing we did. Now I talk about mapping software engineering principles, software engineering and the software delivery into the one architecture. This is how we achieve. So if you look at the organization, project are more close to the software engineering, right? And then so if this is the mistake or the misunderstanding is that if you are running Kubernetes, that's enough for your organization. That is enough if you are only focusing on the operational. But if you are focusing on the software engineering and operational, so abstraction coming from Kubernetes is not enough. This is why we have this abstraction. We have the organization abstraction and project abstraction and components abstraction. And then the right-hand side of you, that is more covering the software operational aspect, delivery and operational aspect. We are data plane mapped into the data plane can be a one or more Kubernetes clusters, and then this data plane can have one or more environment. This is a logical environment, and using this environment, you can define your deployment pipeline. Because of this abstraction, we were able to like combine software engineering and software delivery into the single system. Going more into the abstraction, so project consists of multiple components. The component is like it can be microservices, it can be a manual task, scheduled task, something like that. And component consists of one or more endpoints and connections. And this connection also, this is a very good abstraction we took. Because of this, we can map, design time principles, how apply into the runtime. So because of this, we were able to identify, if there are any anomaly in the runtime, that is not design time, that is not in the design time architecture. And also, with the microservice architecture, we were able to identify, there are a lot of the technical depth built over time. All these things are not using, all these connections are not using in the runtime or in production. So that means we have to refactor our code. So all these things are identified because of this abstraction. Then cell-based architecture. This is the key principle, architecture principle we adhere. So all the project are considered as a single cell. Cell is a logical component. So basically, we are mapping the domain-driven design and the runtime with the cell architecture. So cell can be mapped to if a design time, it can be a domain or subdomain. The single team can own a cell, and they can have multiple components within the cell. These are microservices. So if you are mapped to the runtime, it's a Kubernetes terms, it's a pod. Now, this cell is fully isolated from the other cell. So how we can achieve that? So basically, when you deploy this cell into the production, we attach a Kubernetes namespace, and also we are using underneath Cilium CNI and service mesh. We are applying Cilium network policies to protect this cell. And because of that, only traffic can come inside to this cell via the API gateway. And because of that, we enforce zero trust. Because zero trust means never trust, always verify. So all the traffic coming inside to this cell is always coming to a gateway. That means always authenticate and authorize. And also all the component traffic, network traffic between the components are encrypted using the Cilium network policy, network level encryption. And also all the secret are stored in the key vault with the encryption. So all the security principles are built into the platform. So developer or even platform engineer no need to worry about. They just create a component, it automatically adhere into all these principles. Okay, so I said that we implement a cloud agnostic stack. So this is the CNCF landscape. So if you want to build a cloud provider agnostic stack, you need either use open source or you need to build in-house, right? In-house, it's impossible. You can't everything inbuilt in-house. So you have to use available tools. So the best place to go with CNCF landscape. Then the question is, the given category, there are 10 or 20 tools in the landscape. Now, how you can choose the correct one? So you have to learn all these tools, try out yourself, build the knowledge within your organization, and believe me, it's very hard. So, to know every tool taking a lot of time. So we went through this exercise. We took the challenge. So at the moment, current state, we are using 20 plus this open source project within our data plane. So we invest a lot of time. So now it is not just using inside our platform. We have to build expertise in our in-house. Otherwise, if you are getting an issue, you screwed up, right? So you have to build in-house knowledge, how to troubleshoot it, how to debug it, how to fix it. So like Kanchana said, so we identify some of the issues, we fix it in-house, we send upstream all these fixes. So this is how we engage with the community. Okay, so this is the current architecture in the data plane. This is how we use different tools in different levels. So I'm not going detail, but I can go detail if you want to reach me. So basically, so when you come to the build system, we are using Argo Workflow, and we are using build packs, cloud native build packs to do the build, and we are using Trivi for the container scanning, and we are create a Docker images and push into the registry. So if you're having all registry already having your organization, we can push it to the registry. If not, we can use Harbor. We are using Harbor container registry. To run in Harbor, you need to have Redis, you need to have a cloud native PG, Postgres, all these things you need to run within these clusters. Then after you build, then the CD pipeline triggered, we are creating Kubernetes artifacts. When we are creating Kubernetes artifacts, we adhere in the best practices, and we create all these artifacts, and all the secret configs are in the key vault. We are using, if you are running on AWS, then we are using AWS key vault. But if you are running on on-prem, we are using on-prem key vaults. So when this is the cell enforcement, so we are using WSO2 gateway. It uses Envoy underneath, and then we are using Cilium. We are using a lot of eBPF capabilities coming with the Cilium because we are tapping the layer 3, layer 4 network data. This is how we generate this dynamic service map. Because of underneath, we are all network data captured, and we analyze this network data with the design time architecture and show the differences. Okay, this is your design time architecture, this is the runtime architecture, okay, this is different. There's an issue within the runtime. There may be the compromisation happen in the runtime. There's a data leak can be happen. So all these things can show because of we are underneath running a lot of eBPF probes and the Cilium service mesh. And all the logs are collected from the Fluent Bit running on every node as a daemon set. And we are aggregating these logs to the OpenSearch as a log aggregator. So, and we are running OpenSearch as a high-level deployment. We are running multiple replicas in multiple zones. And we are running multiple indexers. And we are taking the backup to the different regions as a DR activity. Everything we are considered by designing this architecture. And also all the observability data, again, layer 3, layer 4, and layer 7 also. We collect different levels, and we scrape into the Prometheus. And we are running Prometheus as high-available deployment. If you are trying to run Prometheus, it's not easy to run high-available, so you need to have a Prometheus itself doesn't support high availability. You need to use Thanos to make it high availability. Like there are a lot of effort you need to think through to run this as a production grade deployment. We are using KEDA as the auto scale 0 capabilities. If there are no traffic coming to your component, it automatically scale down to the 0 replicas. That saves a lot of money. And also we use Velero as the backup and restore mechanism. And also we are using Hubble observability that again use the eBPF underneath to identify like complex network issues. We save a lot of time by using Hubble data that is underneath. So likewise, so this is the complexity you have to deal with if you are going to develop internal developer platform. Sorry about that. Okay, moving forward. Okay, so to wrap it up, so this is the engineering fact so far we have invested. So we integrate 20 plus open source projects, and we are providing single user interface by integrating all these projects, unified interface. And we are having 60 plus team members. We are doing this more than 4 years now. And we have 15 plus dedicated SRE who are running this with high availability. And we have 20 plus core platform engineers. And now we were in the state that we can run on anywhere in any cloud because of this investment. Okay, so now I think next session, Samira will discuss. So this is what we done last 4 plus years. We are now giving back our experience we built and also the product as an open choreo. I think Samira will discuss detail what open choreo.